thanks again for the invitation, and no need for anybody to bow. You're far too complimentary before I've even started. But yeah, all those sort of awards and things I think are merely just because I've been in this for I don't know how long. I think actually just live off the top of my head, my very first lecture on astronomy was 56 odd years ago to the School Astronomy Club. So I suppose I picked up a little bit along the way. Anyway, let's get going. Right, a little bit of background. What we know about the universe. By the way, this is just a very simple presentation because of the first one. I'm not sure trying any videos or anything like that. The universe is about 13.8 billion years old, an absolutely huge number of stars, which obviously we come on to later, probably an equally huge number of planets. And therefore, if life evolves wherever it can, there must be plenty of it. So what are the chances of ET, in other words, extraterrestrials out there? So first of all, we have to decide what is life. Now, I'm not a biologist, I'm not an astronomer either, by the way, apart from being an amateur one. We don't need to worry about definitions too much. We all have a pretty good idea of what it is. And for this talk, I'm going to refer simply to the two extremes. Very simple life, like bacteria or molds or slime, up to things like amoeba or basic fungi. Or as an alternative to that, which is obviously more interesting, advanced intelligent life, not necessarily like us, but life capable of communicating with us via technology. And just as an aside, I watched Rogue One, one of the Star Wars spin-offs the other night. And the amazing thing was that although this was in a galaxy far, far away, and there are the most unbelievably weird life forms, they all spoke English absolutely perfectly, apart from one. And the one who didn't was actually from planet Earth because he was a Spanish actor and he had quite a strong Spanish accent. But these weird octopi-like characters were able to speak perfect English, but that's the benefit of science fiction. So the next thing is that life is extremely adaptable, even on our own planet. And we used to think, life would live either on the surface or in the air, on the oceans. And it had to be within a reasonably favorable environment in terms of temperature and all the rest of it. We now know it can survive in almost impossible conditions, floating on a lake of sulfuric acid. If you go up to the Yellowstone National Park in America, you'll see that inside barrels of nuclear waste, in water superheated to 122 degrees centigrade, in the wastelands of Antarctica, and rocks 5 kilometers below ground, and even in space. Bacteria and molds and other things have survived on the outside of the International Space Station. You may have heard of little organisms called tardigrades, which are almost indestructible. They say if a really, really big meteorite hits the Earth, almost everything will be extinguished down to the level of a tardigrade. Now, it is a little animal. It's got a mouth and a digestive system and legs and so on. The nickname is water bear, so it's not just as simple as a bacterium. But they are almost indestructible. So that means we have to broaden our horizons quite a bit and look for life in conditions that are much more varied than we originally thought we were looking for here on planet Earth. And this takes it a bit further. You may have heard of the black smokers or the hot smokers at the very depths of our oceans, where the pressure is almost unbelievable. We're talking about 6 miles below the surface, and temperatures where the water is coming out, superheated water from the interior of the Earth at temperatures up to 400 degrees centigrade again. And there are life forms forming around those superheated vents and thriving there. And in fact, they're using the energy from the chemicals that are being taken out, produced in the water, and the heat to thrive. They don't see sunlight. They don't see anything like what we would consider necessary for life, but they're thriving down there. Which takes us to some of the other similar places in our own solar system. The moon Enceladus, one of the moons of Saturn, which you'd see in a good telescope even at the moment. Because it's so far out from the sun, it has a frozen surface, a thick icy shell. Beneath that is a liquid ocean. and beneath that is rock. And because of tidal stresses in Enceladus as it orbits around Saturn and interacts with Titan and so on, it gets squeezed and pushed and pulled, and that is enough to heat the interior temperature enough to make that ocean liquid. It's salty water, but it is water, and it's thought to be one of the most likely places elsewhere in the solar system where there could be life at the moment. And there are all sorts of designs being proposed at the moment for a probe to go out there to look for it. Not easy to do, but not impossible. So to go back again to the very start, excuse me, the general view among biologists, and particularly in astrobiology, is that where conditions are suitable, life will evolve from the complex molecules, such that as those we found in the primordial soup on the early Earth, forming proteins, then self-replicating molecules, and leading on to cells with RNA and DNA, and on to more complex life forms. Now, that's simplifying things enormously. For example, the jump from a simple cell to a cell with a nucleus apparently is a really major jump in evolutionary biology terms, but it happened on Earth, so it's very possible that it's happened elsewhere. So that's one possibility for the origin of life on Earth. A lot of other people, astrobiologists and people like Chandra Wickramasinghe in particular, think that life started elsewhere in space and was brought to Earth by comets or asteroids. And we have already found dozens of complex organic compounds in comets and some in asteroids as well. So that is a possibility. The thing is to expect the unexpected. If we go back to the black smokers at the bottom of the ocean, a nice little cartoon there, if they were intelligent enough to be able to communicate with each other, they might well think that there couldn't possibly be any life at the top of the ocean because there are no hydrothermal vents up there. What would they use for energy? So we shouldn't be too parochial in our search for life. We need to keep much more open minds in the sort of conditions that life might possibly exist elsewhere in the solar system and indeed elsewhere in the galaxy. But on what sort of bodies could life form elsewhere? Well, it's almost a given that it can't happen on stars, although the great Sir William Herschel seemed to think back a couple of hundred years ago that that might have been possible. They're basically giant nuclear reactors with intense heat and radiation and no water, and our sun is a typical star. You could possibly get life on comets and asteroids. They're very small, they're very cold, they've no proper atmosphere, and comets usually have very elliptical orbits. So they vary from being just above absolute zero whenever they're out in the outer reaches of the solar system to very hot whenever they come in close to the sun. And I mentioned asteroids there. Since I did that slide, we've actually now found that there's water below the surface of some of the asteroids, particularly Ceres, the biggest one. And I mentioned Wickramasinghe there before. He's sort of the leading proponent of what's called panspermia, the propagation of life throughout the universe being carried by comets, possibly by rogue planets, possibly by chunks of rock blasted off one planet by a meteorite impact and ending up on another one. And then because of that, some people think that it started on Mars and came to Earth on Martian meteorites, in other words, pieces of Mars that were blasted off by giant impacts, spent lots of time in space, but eventually came to Earth. Could also have gone the other way, but that's another matter. So, right, I'm getting a bit of blockage on my screen there, but just to sort of refresh what we think of as a planet, a medium-sized cold body which is orbiting a star like the Earth or Mars or Mercury or Jupiter. A moon is a smaller body orbiting a planet. Some of them are small, but some are bigger than our moon. And I've already mentioned Enceladus and Europa orbiting Jupiter is another one. We'll mention that as well. Titan, another one, just news breaking today that conditions for life there are actually more favorable than we thought. It has an ocean of liquid methane, but there are now just found today chemicals that are precursors of life. So basically, the more we explore, the more we find that there are options for possible life elsewhere in the universe. I hope you can see that screen properly. As I say, part of my screen is, oh wait, I have to admit, right, that was what it was. I wasn't looking at it. I've just admitted Nigel to the meeting. Nigel, you're welcome. So to summarize very briefly the main bodies in our own system where we might look elsewhere for life, Mercury, I'm not going to rule anything out, but basically these are the most convenient and reasonable assumptions. Mercury is too hot, it has no atmosphere. Venus too hot, a runaway greenhouse effect, a poisonous atmosphere, and no water. But you may have heard a couple of weeks ago that phosphine had been detected in the atmosphere of Venus. There's now some doubt about that. Other people have been trying to find it using the same techniques and the same data, and they haven't found it. It hasn't been ruled out entirely. But phosphine, while it's not life itself, it's an indication that there may be bacteria in the atmosphere of Venus at a height high enough up where the very high temperature on the surface isn't a problem. So the jury's still out on that. My general feeling is that it's probably not, but we don't know. The Earth, obviously, okay. The Moon, no atmosphere, although it does have some water. Again, that was in the news again very recently. Mars is very cold, but there's definitely a possibility that life formed there earlier when it had an atmosphere and temperatures were higher, and it may still be surviving somewhere below the surface. So that's another prime candidate to look. The asteroids, generally speaking, too cold and no atmosphere. Jupiter itself, too cold, except where you go very deep down below the surface, a poisonous atmosphere down there. And if you do go down that deep, the pressure is extremely high. But bearing in mind that we have life at the bottom of our oceans, where the pressure is also exceptionally high, you couldn't rule that out on Jupiter. Things would be very, very difficult to detect. I mentioned Jupiter's moons. The main one is Europa, which also has a liquid ocean below an icy surface, similar to Enceladus. Saturn, similar to Jupiter, too cold. Titan I mentioned, and Enceladus I've already mentioned, so they are two of the moons of Saturn. Now remember, Saturn is extremely far out in the solar system, so it's not getting any life that might be there wouldn't be getting very much sunlight, but there are other sources of energy, particularly the tidal heating that I mentioned. So those are definite possibilities. And Uranus and Neptune, again, even further out, too cold except very deep down and poisonous atmospheres. So what we would conclude from that is while there might be possibly simple life elsewhere in the solar system, it's unlikely that there's any advanced life.